This is a video for chapter 26, and what we're dealing with here is categorical data. So let's scroll down a little bit and talk about one thing that will really help you out here. You can get the expected counts for this by using your calculator. I'm going to slow it down here and pause the video if you need to. To use your calculator to enter this in, click second matrix. That's on the left side of your calculator. You'll see it above the inverse, second matrix. Scroll to the right and hit edit. You want to edit matrix A. Go ahead and enter this in as a 2x3 matrix. Next, you want to click stat test. You'll go down to chi-squared test, which looks like an X with a 2 next to it. You do not want chi-squared goodness to fit. You want chi-squared test. You will let it use matrix A as your observed and matrix B as your expected. It'll actually store matrix B in there for you. This will give you the expected values, and it will give you your Pearson value for the test, your Pearson chi-squared statistic. Well, let's go ahead and look at the jump output for this test. The jump output right here has the Pearson chi-squared value. This value right here is obtained by adding together all the cell chi-squareds. These are the values right here that I'm mousing over now. These are the cell chi-squareds. 6 numbers because there's 6 cells. But how did we get them? Let's rewind the tape. The count is what we actually observe. That's what count is right here. These are the actual observed amounts in each cell. We take these counts and get the expected value from them. To do that, we take row total times column total over grand total. For this one right here, that'd be 66 times 146 over 200 equals 48.18. And you might have this stored in your calculator right now. All you have to do is go to matrix, click second matrix again, scroll to matrix B, you can edit it or display it on your screen, and click it again to display it, and you will see up there in the top left corner, if you did it correctly, 48.18, and you have the expected values in matrix B. So now that we have the expected values, we can get the cell chi-squared values. These tell us how far away something is from the observed. If you look here, 12 and 22 have a big difference, a big cell chi-squared value. 34 and 37.96 have a small difference, small cell chi-squared value. The cell chi-squared value is a measure of how odd that cell is. So to get it, we need to do observed minus expected quantity squared over expected. And we can see that formula back here just a little bit. Observed minus expected squared over expected is the cell chi-squared value. Make sure you know how to do this. Practice this. Go through the practice tests. They're great work to get done, and make sure you know how to do this. When we run these tests, it's very important we understand what the null and alternative is. The null is that there is no relationship between the two variables, and the alternative is that there is a relationship. We show evidence for the alternative. So for this example right here, there is no relationship between type of car and maintenance experienced. The alternative, there is a relationship between type of car and maintenance experienced. I want to highlight one last thing here. What we often don't see here is what to do with the chi-squared value. What we'd actually do with that is plot it over here on a chi-squared distribution. I don't think that's that important to this test. Like I said, I haven't looked over the test yet, even though it has been sent to me. But we would plot that over here at 10.82, and the area to the right of it is the p-value for the test. As you notice, the chance of this happening by chance was very small, and so we would say that we'd reject the null here. I really think the best way to practice for these problems is to go and either do the homework again or work on the problems on the Beast, which might still be open to you right now. We do have some assumptions to mention, so let me scroll to the assumptions real quick. Here we are. We need to have count data, and that is achieved by having categorical. We need randomization independence. We need the 10% condition, and finally, to end this video, I want to make this very clear. We need all expected cell counts to be at least 5. I hope you got to the end of this video because this is a very important assumption. We need the expected cell counts to be at least 5. So scrolling down here, let's check it on this one right here real quickly. Expected cell counts greater than 5. 48 is greater than 5, 37, 59, 17, 14, 22. This would pass. It would pass. Make sure you know all the assumptions and you know how to check them. Good luck.